Hello, everyone. We are the Green Group, and today we will be discussing our earthquake rebuild emissions prediction and sharing our recommendations for rebuilding Haiti. We've put in a lot of effort to understand the impact of the rebuilding process, and we are excited to share our findings. First, let's talk about our emissions prediction. We've arrived at our projected carbon emissions after analyzing data and following the instructions provided to us for use on Google Earth. From our calculations, we've determined that approximately 900,558 tons of CO2 emissions were produced across a 6,393 meters square area of construction. This translates to roughly 140.87 tons of CO2 per meter square. For rebuilding just a small section of a city, to put this into perspective, the emissions in Haiti are significantly lower than those generated during the rebuild following the Great Eastern Japan earthquake and tsunami, where emissions reached about 337.34 tons of CO2 per square meter, while we are producing less than half the emissions in comparison. The amount of carbon generated in the rebuilding process of Haiti remains unacceptable. We firmly believe that these emissions could have been considerably reduced through the use of advanced cement production techniques, sustainable architecture, and more efficient building practices.
We've come up with several recommendations to make the rebuild process quicker, more sustainable, and less carbon intensive. One major idea we had is to use a modular design system. This system would allow us to construct buildings faster while keeping sustainability at the forefront of the rebuilding effort. By using materials designed with sustainability in mind and environmentally friendly practices, we can significantly lower emissions during construction. After researching various technologies for producing cleaner cement, steel, and concrete, we focused on recycling. Cemex's Vertra low carbon cement, Wagner's earth friendly concrete, and CarbonCure CO2 injection technology. Recycling is one of the most straightforward and impactful methods for reducing emissions. By using recycled materials, we eliminate the need for new mining, which reduces the carbon footprint associated with material extraction. The use of low-carbon cement and earth-friendly concrete is another important step. These materials incorporate byproducts like fly ash and slag, reducing CO2 emissions compared to traditionally cement manufacturing methods. Not only are these materials more environmentally friendly, but they also retain the strength and durability needed for construction. CarbonCure CO2 injection technology further reduces the carbon impact by capturing and reintroducing the CO2 produced during the material creation process into the concrete itself. This strengthens the concrete by forming calcium carbonate, which improves its resilience to future earthquakes. The combination of these technologies promote a circular economy where waste from one process can be turned into a valuable resource for another. By using these sustainable materials and technologies, we can reduce emissions while ensuring the rebuild is both efficient and resilient.
Another key aspect of our plan is modular design and architecture. Modular construction involves prefabricating building sections in a factory environment before assembling them at the construction site. There are several advantages to this approach that make it particularly well suited for the Haiti rebuild. The first of which is that modular design accelerates the building process. Since site preparation and module production get to happen concurrently, buildings are able to go up much faster. This reduces disruptions caused by weather and eliminates delays that we often attribute to traditional construction. The result is an overall shorter construction timeline. Secondly, this is much more cost effective. The reduction in labor costs, less waste, and shorter project timelines all contribute to significant savings. Since the modules are built in a controlled factory setting, materials can be used much more efficiently, and this reduces the waste and the associated costs of generating that waste. Additionally, labor costs are reduced because workers can focus on the assembly rather than the extensive on-site construction. The third advantage is that modular buildings are often of higher quality. Since the modules are produced in a factory environment which has controlled conditions, they are built with better precision and durability. Traditional construction is susceptible to environmental factors like rain, snow, or varying temperature. This can affect the quality of the final product. In contrast, modular construction minimizes these risks, and it ensures better performance in the long run. The final advantage is that modular construction is generally more sustainable. The aforementioned reduction in waste conflated with the potential for better energy efficiencies are key advantages. Since modules are manufactured in factories, leftover materials can be recycled and reused. This reduces the overall environmental impact of construction. The shorter construction period also minimizes the pollution generated in the surrounding areas. This makes modular design an environmentally responsible choice. By integrating modular design with the use of sustainable materials, we can rebuild Haiti in a way that is faster, more cost-effective, and environmentally responsible. This approach is not only good at reducing the emissions, but also creates stronger, more resilient buildings that can withstand future disasters, thus ensuring a better future for Haiti's residents.